So let us talk about the sampling distribution. Sampling distribution. So suppose you have a collection of data. Let us begin by definition. A sampling distribution is a probability distribution of a sample statistic. Remember that when we talked about sample statistic, we said we have X bar as the mean of the sample, or we can work with P hat, which is the sample proportion. So a sampling distribution is the probability distribution of a sample statistic, either the mean or the proportion. It is formed when samples of size n, repeatedly taken from population. Very well. If you're working with the mean, then we call it the sampling distribution of sample means. So if the sample statistic is the sample mean or X bar, then this new distribution, is called the sampling distribution of sample means. If the sample statistic is the sample proportion or P hat, then this new distribution is called the sampling distribution of sample proportions. Then this new distribution is called the sampling distribution of sample proportion. When we are working with a sample statistic, just let us focus on the mean and the proportion for now. If you are using sample statistic, mean or proportion, if you repeatedly take samples outside of population and calculate the mean, then this new distribution that we created is called sampling distribution of sample means. So we have a population. This is a large population that we have. Well, we're taking samples from this population and finding the mean of those samples, x of 1 bar, x of 2 bars, x of 3 bars, and so on. These form a new distribution that we call the sampling distribution of sample means. Instead of working with x, we are working with the means of those samples. However, if you are working with proportions, it means that we have a large population. We have a large population, and we start taking random samples from that population and find the proportion P1 hat from the second sample, P2 hat from the third sample, P3 hat, and so on. These sample proportions form a new distribution that we call the sampling distribution of sample proportions. You need to know these definitions. These definitions are important. We're going to use these again when we are dealing with confidence interval. So why we are interested in building this new distribution? In many cases, your population is not normal. So if the population is not normal, then you are not allowed to use the formula that we defined for a normal distribution. Note that in many cases, the population is not normal. To make it normal, we create a new distribution. This distribution is either the sampling distribution of sample means, or it is a sampling distribution of sample proportions. Depends on which one is the case of study that you're trying to analyze. Very well. So what is the central limit theorem? The central limit theorem says if we have the following conditions, if samples of size n, where n is larger than or equals to 30, are drawn from any population, it means that it doesn't matter if that population is normal or not. If we take samples of size larger than or equals to 30, then the sampling distribution of sample means is approximately normal. Very well. If this happens, then we can calculate the mean for this new distribution. The mean denoted by, so we have a new distribution. The mean denoted by mu sub x bar. Mu sub x bar. It happens that this new distribution has the same mean as the mean of your population. Mean of the distribution is the same as the mean of the population. That's the meaning of that. For this new distribution, we have the mean, and we also have the standard deviation. The standard deviation of this new distribution is denoted by sigma sub x bar. And we have to do a little bit of calculation. This is equal to sigma divided by square root of n. So the standard deviation of the new distribution is the standard deviation of population divided by square root of n. So again, central limit theorem says for any population, if you take samples of size n, which are larger than or equals to 30, this condition must be met for any population. Then you are forming a new distribution by taking the means of your samples. So again, here you have your big population. It might be normal, it might not be normal. You start taking samples, random samples from this population. X1 bar, you calculate the mean of these samples, X3 bar, and then you take these numbers. There are a lot of them. You construct a new distribution, which we call the sampling distribution of sample means. This new distribution based on these new data has mean, and also it has standard deviation. The mean of this new distribution is the same as the mean of the population. So we're not really worried in calculating the mean of this new distribution. However, to calculate the standard deviation of this new sampling distribution, we have to do a little bit of algebra. Sigma divided by square root of n.